So we're writing dissociation reactions. And Calvin, if you point up there, so for Ian, on review day, what we usually do is we write down what kind of problems you're going to have. So for their particular test, they have 3 dissociation equations, which are what they're doing right there. And then we're going to go through the other types of problems here, and the point values are listed too. Okay. All right, so let's see what we got here. We got some problems. Let's go through this. You guys are good. Let's see what we got. All right, so first of all, if you're going through a dissociation equation, what should the state be for the initial thing? This should be a solid. Okay. Now, couple problems here. One more problem here. Because he has Fe as a +3. Okay, and I'm going to tell you that that's not right. Okay. Now, one way you could do this, right? One way you could do this is to go look at your periodic table. And when I go look at my periodic table, I see iron can be +3 or +2 when I look at the oxidation state. So that means I have a problem. I got to figure that out. So what you really have to do, the only way you can do this, I'll show you a shortcut later, but we haven't learned that shortcut yet, is this. You know SO4 has to be a -2, because that's on your polyatomic ion sheet. This thing has no charge. Therefore, iron can't be +3. It must be what? +2. It's got to be +2, so that +2 cancels out that one. So that's +2. So I'd say, like on a 5-point problem, he would have probably lost 2 points on that. All right, so that would have been. Now this one, got some problems, right? Yes.
Wait, why is it 2
What's that?
Why is it
It's got to be +2 because these 2 charges got to cancel out because this thing has no charge. If this thing was FeSO4 +1, then this would be +3, and that'd be -2. Now this one here, whenever you see lots of atoms, you're probably dealing with a polyatomic ion. So we've got KMNO4, and this has got to be a solid, so we're missing solid. Yeah, you're putting it into water. Well, it breaks up into 2 pieces. Well, what 2 pieces? K and MnO4, which is a polyatomic ion on your sheet that's negative. Potassium's group 1, so that's +1. And since these are dissolved, they're both aqueous. Okay. You know, if you need more of those to do, somebody's just got to post something in Modo, and I'll give you more.
Just for the sake of the question, if the O was separate, the subscript 4, that would go in front of the O, right?
It just can't happen. And let me just say it that way. I know what you're saying, okay? Yes, but it can't happen. Okay?
What do you mean? Can't happen?
If O splits off, it's actually going to split off as O2.
Oh.
So it'd be 2O2.
Okay, so say it was like phosphorus instead.
Yeah.
Then it would be. Okay.
Yeah. But even then, phosphorus would probably be P4. That's what I'm saying. I know what you're saying, and yes.
Okay.
Yes. It would come out as a coefficient, but it just can't happen in this particular instance.
Okay.
So, like if it was Na3, it would be 3Na+.
Okay.
Right. Okay. So first thing I would say is, if you don't know how to do that, that's going to present problems for you here for sure. Okay? Because that's concentration of ions is dependent on you being able to write a dissociation equation. So like for this one and for that one, for every one of these, you get 2 of these, right? 2 ions, so it's a 2 to 1. Can we move on? Because that stuff will come up again in other problems. Right, so just to be clear too, remember this is you take a solid, you put it into water, and the reason it breaks down is because our crystal, like here's an NaCl crystal, each one of those atoms gets surrounded by a sphere of water. Remember, water's got that V shape, like this. Here's a water molecule, and in this there's an oxygen and 2 hydrogens, and these 2 hydrogens are sharing electrons with that oxygen. But this oxygen's like big brother, he's a bully, and he steals the electrons more of the time, and these guys are like little brothers, they get the electrons less of the time. So more of the time the electrons are up here, less of the time they're down here. So more of the time this is slightly negative and this is slightly positive. Slightly negative N can interact with positive charges, slightly positive N can interact with negative charges. So we get bubbles of water forming around those ions. And you get that until all the water is taken up and then you can't dissolve anymore and we say it's saturated. Okay, so let's see. Okay, let me do it like, I think I'm going to do it this way. I like this better. So this will take me 2 seconds, but I like it when I can put the actual problem right up on the board, so I'm going to do that real quick. So this is, should have had this ready, but such is life. Textbook, 7th edition, oh, and page 171. Okay. Okay. Yeah. Okay, let's see. Click. Okay, you're gonna wake up, good. Okay. All right, there you go. All right, so let's get some guys up here. What do I do with my cards? Here you go. All righty. All right, first one. Jarrell, come on up and do something productive. I want this on the pointer. Something productive. Oh, by the way, I'm sorry. I cut off a little bit too. The original thing says calculate the molarity of each solution. That's what it says at the beginning of the problem.
What's the molarity type?
Yep, it says calculate the molarity. So I'm kind of giving Jarrell a hint right now. Calculate the molarity of each solution. Jarrell, check it out. Calculate the molarity is what it says before, but that's not written down here. So what can we write down if we have to calculate the molarity? Jarrell, I'm trying to give you the answer right now. Calculate the molarity. What's that mean to do? No. Guys, listen up.
Yeah, I don't know.
It tells you to calculate the molarity.
I don't know how to do that.
I know. But you know what you're being asked, right?
Kind of.
What am I asking you?
Calculate the molarity.
Okay, so let's write that down, that you want to figure out what molarity is. No, what's the letter we use for molarity?
Right?
Is that a lowercase or an uppercase?
Lowercase.
Nope. Okay, equals. There you go, question mark. Okay, so you did something productive, right? Calculate the molarity, all right? All right, Carson, something useful. Now, I'm not arguing with you because you do need to do this, but how do you know you need to do this? Wait, I'm asking.
You need to do 184.6 of that times 1 mole of it start.
Yeah, but why?
To find the mole.
And why do you need moles? You're not wrong. You're right, but I'm just asking you why. I'm wondering why you jumped to that first.
Because you need to find moles of solution over.
There you go, because you're looking ahead, right? So let me just make a point here, because what I'm saying is this, is that when you write down M equals, and I knew Jarrell was kind of a little bit lost there, it means moles of solution per liter, right? So now Carson's looking at this and saying, well, I know I need to get moles, all right? And I can see I have a mass, so I know I'm going to need molar mass. I'm going to calculate molar mass. Make sense? Now, the way that I would go about this is what I suggest the most to you guys, is first read through the problem and find all your questions and all your data first. You get what I'm saying? Get organized first, then start doing calculations. But I'm not going to argue with him. This is fine. You can go ahead with what you're doing. But do you guys get my point? Find what's in the problem first before you start calculating things, because maybe you don't need to. Maybe it's in the problem. Maybe it's something that they're not asking for. There's one up there someplace, probably underneath my book right there. Probably under the lid, I would suspect.
112.
I always take math like that and break it down into two things, 7 times 10 is 70. 7 times 6 is 42. I can do that in my head a lot quicker. Okay, so what are the units for that, though?
Star grams.
Okay, what is that?
Just grams.
Grams,
Over. Mole.
moles, yep. Okay, all right, Adam Upperman, something productive.
Oh, you got to.
What we gonna do? Ooh. Ooh, no unit?
What?
No unit?
Oh,
Whoa, MG. Ooh, we're not going to be able to do that. Why not? What's this written in terms of? And that is?
MG, so you got a nice.
So what's the problem we have? Change milligrams into?
We have 294.
I don't think we want to go there either.
I have no idea what to do.
Well, you would know what to do if it was just grams, right?
Yeah.
So what do you got to do before you go and do that step? You got to take milligrams and turn it into. No, we're not ready to use that yet.
I have no. So I put grams and milligrams. I know that. So